Hello everyone, it's Benny, and welcome back to the audio programming tutorial series. In this video, we're going to be talking about pitch. How can we take a sound and play it at some higher or lower pitch? And as it turns out, this isn't that hard, at least not in the basic form. Let's say, just for example, we have a sound that's at 50 Hertz. Now what does that mean, you might ask? All that means is that the sound wave that looks, let's say it looks something like this. There we go, that's a sound wave. The sound wave is repeating itself 50 times every second. So there we go, that's all that 50 Hertz means. That's all it means if a sound is at a pitch of 50 Hertz. It's some sound wave that repeats itself 50 times per second. And now, let's say we want to play this at a higher pitch. Let's say we want to play this at 100 Hertz. How do we do that? Well, think about it. If the sound is some sound wave repeating itself 50 times per second, if we want it at 100 Hertz, then we want that sound wave to repeat itself 100 times per second. So, if the original sound wave is something played 50 times per second, then all we have to do is play that sound twice as fast. And it's really that simple. Just take the sound, play it twice as fast, go through the sound file twice as fast, and it'll be played at 100 Hertz. Why? Because now we're playing that same sound wave 100 times per second rather than 50. There you go, that's all there is to playing at different pitches. And same sort of principle if you want to play at a lower pitch. If I had, say, a sound that was at 100 Hertz and I want to play it at 50 Hertz, I just play it at half as fast. And there you go. So, let's go ahead and let's implement this. So, in code terms, what this means is we're going to need to increment the samples pointer at some variable rate. We might want to do plus equals 2, for instance, if we're doubling the pitch. We might want to do plus equals 0.5 if we're halving the pitch, even though technically this code right here won't work. But you know, that's the idea. So you might be wondering, how are we going to do that? Well, there's a few small changes we're going to need to do in order to support that. Most notably, well, maybe not most notably, but something we're really going to want to do is we're going to want to change this termination check. We're not going to want to rely on length left anymore. And there are things you could do to length left here that would make it work. It's not like this is magically going to be broken, this method isn't valid anymore. It's just, now that we're not going through the clip, well, sample by sample, checking if we have no samples left isn't going to be quite as reliable. What if we're going at 3 times pitch? We're going to be going through the samples array 3 times as fast. We might skip the final sample for some reason, and then this condition won't go off. So it's going to be a better idea in the long run to do this with pointers. It's not impossible with length left, it's just pointers are going to be a little bit easier. So we're going to check if our position is in the range, if our position is past the end, or if our position is before the beginning, well, past end. Excuse me. Then we know we're outside the clip. We don't need to worry about it. There you go. All done. Don't need to worry about any weird issues of how fast are we going through the remaining length. Just, are we outside the range? If not, if we're outside the range, then therefore we're done with the clip. And so I can actually move this down here where I think it makes a little bit more sense. The next thing we're going to want to do, now that we've got that out of the way, is we're going to want to access samples by index. So we're going to access this more like an array rather than like a pointer. So I have some size t I'm going to call sample index. It's going to start at 0. And every time through this loop I'm going to say samples index plus plus. And in here we're going to say samples sub sample index instead of just dereferencing samples. And there we go. Now the only thing left here is now when we're casting samples back to impos, this isn't necessarily going to be accurate. So we're going to do samples plus sample index so that we're at wherever it left off. And there we go. This should, if you build and run this, it should work just like before. And there, now we can do what we need to do to adjust, well, go through the samples at variable rates. So, now that we've done that setup, going through samples faster or slower is going to be pretty easy. I'm going to have a float pitch variable that, for the time being, I'm just going to hard code, but we're going to make this more general very soon. And all we have to do, sample index, rather than incrementing, we're going to plus equals the pitch. So if I set this to 2, for instance, we're going to double the pitch. If I set this to 0.5, we're going to halve the pitch. And that's the way this is going to work. But for now, I'm just going to leave it at 1. Now, when we do this, we're going to want to change sample index to a float, because that way it'll keep track of any decimal places here. If I want to do 1 point this, it'll accumulate the decimal places and go through that properly. So, I'm going to cast sample index here to a size t, and there. And it is okay to cast, just do a basic cast here, because sample index should never end up being negative. We shouldn't be accessing negative elements of the array. And there we go. So with that, we've almost got everything we need. There's just one subtle thing here, and that's with the length variable. Now, if I have a pitch of, say, 2, then this length left here might not be accurate. Why? Because we're going through the length twice as fast. So saying we have this many samples left, technically true, but again, we're going to be going through them twice as fast as normal, so it's not a good way of deciding whether or not we have enough samples to fill out the rest of the buffer or not. What we're going to need to do is we're going to need to either adjust the length variable here, so that we do this, say, times pitch. And that way, this length represents, well, how many samples we're going to literally go through. And that's one way to do it. But the other way to do it, the one I'm going to be doing, is where we do this divided by pitch. And what this is going to do is going to keep everything pretty much exactly with, well, length is going to retain its meaning. It's not going to mean the number of samples we need to go through. It's going to mean, well, how much of this stream buffer we actually need to copy to. And so therefore the rest of the code remains valid. And with that, we should be pretty much good to test. The only thing I'm going to do is I'm going to not hard code pitch anymore. I'm going to get this from our sample info. We're going to get info.pitch. That means we need to change sample info so it has a double pitch. Oh, that also means we need to go back here really quick and cast this to a float. Not necessary, but avoids a warning. And if I go here, I'm just going to say info.pitch equals 2.0. And if I build and run, we should hear the audio clip played extra fast. So, let's go ahead and build and run. And if I press A to play the clip, we should be able to hear my voice at twice its usual pitch.
Hello everyone, this is Benny from the past, and you are hearing an audio clip played by a computer program.
So there you go. That's what my videos would sound like if I was a chipmunk. Now you know. So let's try lowering the pitch this time. Let's see if I do something crazy. There we go. Just some wacky keyboard mashy thing. Let's build and run, and let's see what happens.
Hello everyone, this is Benny from the past, and you are hearing an audio clip played by a computer program.
And there you go. That's what my videos would be like if I had a really deep, soothing voice. Now you know. But something you might have noticed that time is there's something a little bit robotic about that. It sounded a little bit staticky. It sounded a bit weird that time. And believe it or not, there's a reason for that. There's a reason our pitch adjustment sounds so weird and robotic. What is it? How can we fix it? Find out next time on the audio programming tutorial series. Hope you enjoyed, hope you learned, and I'll see you next time.